Welcome in Dark Core. In May 2022, for the first time, the world saw what the mysterious monster in the heart of the Milky Way looked like. Astronomers revealed a real image of Sagittarius A** AY times STAAR, the black hole at the center of our galaxy. In 2019, an image of the black hole located in the distant galaxy, MES times EE times AY, Messier 87 was captured. And it looks much like Sagittarius A**, but their similarity is no mystery. The mass of the black hole in our galaxy is more than 4 million times that of the Sun. Sagittarius A** is located 27,000 light-years from Earth, and finding it in the sky is no easier than spotting a donut on the Moon. But Messier 87 is much further, about 50 million light-years away. So why was the image of Sagittarius A** taken much later, and why was it so difficult to do? What secrets does this space region hide from us? INTRO, scientists consider the Milky Way to be one of the oldest galaxies in the universe. It formed about 13.6 billion years ago, so it's almost the same age as the universe. To grow and mature, the Milky Way has merged with other galaxies, and it's now colliding with the dwarf galaxy Canis Major. This is how the Milky Way grew to a huge size, amounting to a diameter of 100,000 light-years across. It consists of a central part and 4 large spiral arms, making our galaxy a barred spiral. The Earth is located in one of the quietest places, a small arm of Orion. The center of the Milky Way is located far away from our planet, at a distance of about 25,800 light-years. There, as in the heart of any big city, life is in full swing. But because of the dense cloud of gas and dust, it's difficult to see even with the most modern telescope. But what if we could move our planet there? As we would approach the center of the galaxy, the ring of stars would shrink around us more and more. The Earth's magnetosphere would no longer protect us from radiation. Let's suppose that we somehow managed to pass through this area at a safe distance, from supernova explosions that are common in such regions of space. It would still only get worse from there. We would fall into the clutches of the supermassive black hole because there's no way we could bypass it. Even at a distance of 20 billion kilometers, 12.4 billion miles, this monster pulls everything inward at a speed of 25 million kilometers, 15.5 million miles per hour. The path would lie through a dense cloud of gas and dust, the debris of stars, which would probably blow the Earth to pieces before being swallowed by the black hole. So it's better we stay in our quiet and cozy arm of Orion, and study the center of the Milky Way with the help of telescopes. But for a long time, scientists couldn't break through the dense cloud of gas and dust. So the existence of the supermassive black hole lurking in the middle of the galaxy was just an assumption. It was only confirmed with theoretical calculations. Observations also showed that stars are attracted to the center of the galaxy by an incredibly massive object. However, any image of the black hole was just a computer simulation. To get a real image of it, 300 researchers from 80 scientific institutions around the world created a powerful, Event Horizon telescope. It connected 8 radio observatories around the globe, forming a single virtual telescope the size of the Earth. But this was just the beginning of the hunt for Sagittarius A*. To understand all the complications, let's go back to the black hole from the M87 galaxy. The mass of the giant is 6.5 billion solar masses. The accretion disk makes a rotation around its center within a span of several days or weeks. Sagittarius A** is much smaller, and its accretion disk has an orbital period of just a few minutes. So the brightness and structure of the black hole's halo change at an incredible rate, which prevented astronomers from capturing an image of Sagittarius A*. To succeed, researchers have developed new sophisticated algorithms and programs. Then, for weeks, they collected data on the black hole. The information received was processed using a supercomputer. The result was a stunning shot of the massive black hole. However, this region of the Milky Way keeps surprising scientists. The most astonishing discoveries were made by the new generation radio telescope Meerkat, located in South Africa. The whole thing consists of dozens of antennas that widen the telescope's field of view. As a result of 144 hours of observations on Meerkat, and 70 terabytes of processed data, astronomers created this unprecedented image. This is what the center of our galaxy would look like if people could see radio waves. This is a very detailed picture, and every object in it is kind of a mystery. This is a spherical supernova explosion, and here, on the right, you can see an unknown object that looks like a comet with a bright tail. However, it's not a comet but something still unknown to astronomers. Another interesting, tailed, radio source is also visible nearby. It probably moves at an extremely high speed, and as a result, leaves a trail behind it. Here, a mysterious mini-spiral sticks out of a black hole. According to scientists, it may be a stream of ionized gases rushing into space from the depths of Sagittarius A star. And this image illustrates a much larger, and quite bizarre object. Giant magnetic tentacles extend from the core of the Milky Way. Astronomers believe they stretch for 150 light-years. These tentacles resemble threads arranged in pairs or groups, like strings on a harp. And they are separated from each other by about 1 astronomical unit. These peculiar cosmic wires are pierced with electrons accelerated to near the speed of light. The mysterious filaments were first discovered back in the 1980s, and the new Meerkat image uncovered thousands of new ones. This is 10 times more than previously discovered. Finding these cosmic wires was a difficult task as they strongly merge with other objects in the center of the galaxy. But Meerkat can detect synchrotron radiation, or radio waves generated by the movement of charged particles at near light speed. Combined with software image processing, the advanced technology eventually made it possible to catch the threads on camera. Astronomers named these structures after the terrestrial creatures they resemble: pelicans, mice, and snakes. But the secret behind the origin of this galactic menagerie remains a mystery. The filaments may have been created by the magnetic fields of excited gases escaping from the black hole. They are intertwined with starbursts and supernova explosions. It turns out the galactic filaments are enclosed in cocoons, 2 giant bubbles that emit radio emissions. These 1,400 light-year arrays extend from the black hole in opposite directions, forming 2 halves of an hourglass with the black hole at its narrowest point. The thread-filled bubbles look like carefully woven, exquisite pieces of cosmic art. And they probably appeared millions of years ago as a result of a severe cosmic cataclysm. Astronomers consider several options for what might have happened. A squall that rose after the simultaneous explosion of many stars could have filled this region of space with a huge amount of energy. Or a black hole swallowed nearby stars too fast and let some of the gases out. But regardless of what happened, the disaster was on an enormous scale. It provoked a colossal surge of energy that pierced the interstellar medium and gave birth to gas bubbles. The electrons inside them are still in an excited state, and together with nearby magnetic fields, they emit radio waves. Still, these structures are like little soap bubbles compared to giant Fermi bubbles, which were discovered in 2010, and stretch above and below the galactic center by as much as 50,000 light-years. They are millions of times more massive than the Sun and emit gamma rays at a higher energy level than the Milky Way. A decade later, with the help of the Wisconsin H-alpha Mapper telescope, astronomers learned more about the Fermi bubbles. Researchers found ions in them that formed as a result of an intense light flash. The event happened about 3.5 million years ago, but the gas in the bubbles is still about 8,500 Kelvin, 15,000 degrees Fahrenheit. With the new data, scientists hope to test models of the Fermi bubbles against observations. In 2020, the EROSITA telescope discovered another pair of bubbles. The EROSITA bubbles are also hourglass-shaped, and they are visible in the X-ray range. This image here shows a comparison of the Fermi and EROSITA bubbles. Both look quite similar. And although they could have originated from the same cosmic catastrophe, scientists are certain that these are different pairs of bubbles. It's possible that the black hole Sagittarius A* sucked in a massive cloud of hydrogen and then ejected a huge amount of energy. Another idea is that there was an explosion of a huge array of stars. Bubbles could also be born as a result of both events working in tandem. According to Andrew Fox of the Space Telescope Science Institute in Maryland, in the latter case, the flash would have had unprecedented power and lit up the entire galaxy like a Christmas tree. Astronomers hope to confirm this version soon. EROSITA is currently completing its second visible sky scan. Perhaps, the new data could reveal the clues behind the nature of the mysterious bubbles. Meanwhile, another team of astronomers is trying to explain a cosmic event that is already on the verge of mysticism. Strange radio signals are being sent to us from the center of our galaxy. In 2021, astronomers picked up these signals, ASCAP J173608.2-321635, with the ASCAP radio telescope in Australia. The signals were intermittent, lasting 15 minutes a day for several weeks. Then the obscure galactic signals went silent. Later, they were spotted again by the Meerkat radio telescope. Astronomers have detected 6 signals within 9 months of 2020. What's weird is that their radio frequency didn't match any frequency known to science. Astronomers were also amazed by the high polarization of space signals. This means that the electrical signal of radio waves was restricted to a single direction. Scientists looked for explanations, and they considered pulsars, which are rapidly rotating neutron stars. Pulsars are magnetized and emit strong radio emissions. But the unknown signals didn't correspond to the type of such celestial objects. Magnetars didn't work as an explanation either. Their radio spectrum is quite different from that coming from the galactic center. So far, astronomers have settled on the idea that these were the signals from a new type of a stellar object, still unknown to science. The phenomenon has some common properties with other unexplained signals, galactic center radio transients, GCRTs. 3 such signals were identified in the 2000s. But the sources of GCRTs are also poorly studied. So it's still too early to talk about their common nature. Who or what do you think is sending us signals from space? Let us know with a comment and give us a like if you enjoyed the video. And to make sure you don't miss out on anything incredible happening in our universe, stay tuned here by subscribing. Thanks for watching Dark Core.